Good afternoon. Thank you for joining the second session after lunch. Hopefully everybody had a good sleep for the first after lunch. Everybody had a coffee. So everybody's awake now, right? So we can have some good discussion. We are very excited to be here to talk about our experience from a DevOps perspective in CapitalOne. And hopefully you will get something out of it. And happy to discuss offline after this session as well if time does not permit. We are very excited. I just want to quickly introduce two of us. My name is Rajesh Kumar. I basically lead the software delivery and production operations experience at CapitalOne. And I have my colleague here, Ishu Gupta. He also is a software engineer within my team. We are very excited to be here in San Francisco. We both work out of Dallas, and pretty warm weather. Nice to be here. Pretty cool, actually, this time of the year. So we are very excited, actually. So what I'm going to do is I'm going to basically talk to you, give you a story, and talk to you about our experience, how we went about it, right? And hopefully this will resonate with all of you and see whether it makes sense what we are doing and how you can pick something from this, or maybe we can learn something from you guys. That's what the intent of this presentation here is, actually. So so CapitalOne, as you all know, it's basically, as you know, we heard in the keynote presentation, every company has to become a software company. So we are a software company. We basically provide a financial product, right? That's basically CapitalOne is. So CapitalOne started the whole digital transformation journey almost like 6 years back. So we are much advanced in terms of the transformation. So from our perspective, the DevOps is not something which is very new to CapitalOne. We have been practicing it for probably more than 4 years, actually. But what I'm going to talk about today is more about how we reimagine the entire experience in the last 1 year. And so this whole story is about how we changed the way we have been doing DevOps in the last 1 year. And that's what the intent of this presentation here is. So the first thing what we did was that, as somebody mentioned, that everything is all about product, right? So the first thing we asked ourselves here is that, okay, we have a pipeline, but what is so great about it, and is our customer happy? So the question came for us was that, who is our customer? That's the first question we need to ask ourselves. Is CIO is my customer? Is the operation guy is my customer? So we came out, we said, no, our customer is actually these two people. The software engineer, we can call it them developer, and the SRE. So that's the first thing we said, okay, we need to know who our customer is, because unless you don't know your customer, you don't know what the pain point they are having and how would you go about solving the problem for them, actually. So that's the first thing we did that. So once we identified the customer, then what we did was that in any design environment, you go through what I call the journey map, right? You go through the whole product cycle and you talk about the customer. So what we did was that we basically went through this whole customer journey. We spent a lot of time with our developer community. We started talking about them, hey, in terms of, hey, what the pipeline we have, what are the challenges you are facing. And as in the previous note, somebody talked about microservice, cloud, agile, DevOps, everything is all coming together, right? I mean, this is no unique to CapitalOne. I'm sure a lot of the organizations are going through the same journey, actually. So what we did was that we took the entire conversation with our customer and we mapped them into what I call the 3 experience that we came out. And this is where I want you to pay attention. So what we did was that we said, okay, in the entire life cycle of a software, typically a developer or a software engineer goes through a product which is the intent, and then basically we have something concept called architecture and design. Then basically you talk about software delivery, and then once you build your software, you deploy it, and you talk about the production operations. So what we did was we took the entire experience and we mapped into what we call the 3 sub-experience called architecture experience, software delivery experience, and production operations experience. I, fortunately enough, get to lead the 2 experience. We will not talk about the architecture experience today, so I just wanted to call it out. The next thing what we did was that once we identified what the experience is, we came out with a vision statement. We wanted to have a bold vision. So the 2 vision statements that we came out was that for the software delivery, we said, we want to have a quality software delivered now. It's almost like we're talking about, I want to deliver as and when I want, actually. But it has to be, the key here is the quality, right? So that's the vision statement we came out with. And then for the production operations experience, we said, we want to deploy from the couch, monitor like a breath, secure like your thoughts. That's the vision we came out with this 2 experience. So the next thing for us was, okay, now that we have a vision, let's identify what the goals are. So then we said, let's look at what are the pain points. So this is the 6 areas we said we're going to focus from this 2 experience, actually. That's what we said. Because obviously, unless you decide where you want to focus, you cannot channel your energy, actually, right? So these are the 6 things we focus. We said, all we want developer is to write code. Isn't that's what the software engineer wants? They all want all day to write code, right? Not worrying about how the build happens. Of course, they're responsible for making sure the build is done correctly, but at the end of the day, they're looking for some kind of a freeway, right, or a highway, where as long as you are disciplined, you can move your code, actually. So we talked about let developer write code. That's a mission we came out of the first one. The second one was that very early we decided to map and go to a containerization strategy. So we made it very clear that in financial service, where Ishu and I come from, we made it very clear that if you want to deploying an application, it has to be containerized, period. No discussion about non-container. That's the second goal we decided. The third was everybody talks about no fear release, right? We all have gone through our life where we have to awake in the night at 9 o'clock, open the bridge, maybe engage with the change management. I don't know how many of you have gone through that cab, making sure that release happens, and we are keeping our finger crossed. Hopefully everything should go well. If not, then we have to do a firefighting, figure out how to roll back. I'm sure we all have gone through that journey, actually. We wanted to basically reimagine the whole release management, which sounds very boring, actually, at the outset, but we had to reimagine and make it easier for our software development community to say, you know what, you can release your software any time of the day as long as you meet the requirement. So we brought the concept called no fear release. The fourth one was always on. What this really means is very simple, is that every application that we deploy, we cannot afford to have our application downtime, period. Because today, our modern applications have customers that, for example, if CapitalOne.com goes down even for a minute, it creates a bad experience for our customer, which means that our application has to be always on, which means that we have to channel, we have to power applications such a way that they're always on. That's the fourth area. Fifth one, which is very important, which is do the right thing. What this really means is that we definitely want to build the software, but we need to do the right thing, which means that the quality aspect. That's the fifth we came out. And the last but not the least, which is now where CapitalOne is going big time, which is you build, you own it. Right? That's the basically. So this is 6 areas we said we're going to focus it, and that's where in the last, I would say probably a year, we have been focusing, and what we're going to talk to you for the rest of the presentation is what and hows, actually, right? All right, so the first thing we said was from a developer code, we said the 3 or 4 areas we said, which is very important. One is that create an easy path for the developer to access various enterprise systems. CapitalOne, just like many of you who are working in a large organization, and we constantly hire people across the time. And every time a developer, software engineer comes to CapitalOne, it's a nightmare scenario where they have to know so many different CapitalOne ecosystem where they can start writing the first line of code. So we had a situation where for a developer to write the first line of code, they will have to spend probably maybe a week or even a month to basically onboard to different ecosystem within CapitalOne, right from your access to, I'm sure all of you can correlate this kind of a pain point. And that is by no means a great experience. So we wanted to basically reimagine the entire onboarding experience. That's what we'll talk about that. The second one was that we wanted a pipeline to be developer-centric. What this really means is that developers is one community which I have experienced myself, and I used to be there once upon a time, which is that when things work well, we don't provide the feedback, but when things don't go well, we are basically complaining, right? It's very difficult to predict this community, actually, what they really want. So we wanted to make sure that our pipelines are basically developer-centric. Make sure that everything is transparent. What this really means is that as a part of your build pipeline, this is where I think today, one step we talked about DevOptics, actually, right? That's what the Jenkins brought here. I think I don't know how many of you have gone to Hygia booth, which is CapitalOne open source solution called Hygia 3.0. So everything is all about transparency, making sure that developer is in total control of the pipeline. And lot of things, every pipeline needs to spit out events. So we basically made it very clear that as every aspect of the pipeline, as you move in the journey, make sure that events are generated and developers have a full control over the events where they can pretty much know what's going on in the pipeline. So we made basically a logo which says, I really don't want any developer to reach out to us on Slack. I don't want developer to come and say, you know what, my build is failing, can you tell me what's going on? That's not to be in a good path, actually, right? So that's what basically we wanted to do that. The second aspect was, which is the do the right thing. And this is basically means is security first. CapitalOne is a financial company, just like any financial company. It's very important for us to make sure that we are dealing with the customer data. And it's very important that security should come first to us. It should be a natural enabler. It should not be afterthought, actually. So we made sure that whatever software delivery experience we are building the security is a part of the experience itself. That's the first thing we called out. And then the quality, right? This is very important because we want to deploy the software in the fast way, but at the same time, we don't want to compromise on the quality, which means that whether it's an open source violation, making sure that you're doing the right testing, that has to be ingrained in your software development. This is not a nice to have, but it's very important. So we made sure that that is not compromised. And the last but not the least is, which is reusability. For any large organization like CapitalOne, it's very important that we don't keep building the same product in silos. So we made a concept making sure that everything is reusable so that if I have developed something and somebody can reuse it, let's have the reusability rather than somebody else building the same thing. So that's the second concept we brought in. The third for us was the containerization. And I think there's a lot of conversation going on in this conference about Kubernetes and everything. We are also going big force in the Kubernetes. Right now, we are completely AWS, so we are using ECS for our basically container orchestration strategy, and we have been very happy with the outcome, actually. But for us, the key was that when we went to the cloud, which I think CapitalOne started almost 2 to 3 years back, actually, what we found was that even after being in the cloud, the cost of our infrastructure didn't really come down. So on one side, we found that data center environment was restricting us in terms of free to go about going and deploying things faster. Cloud really helped us. But in the cost-wise, we still found that we are spending a lot of money in the infrastructure. In fact, our CIO said that on an average utilization of CPU is not more than 4%, actually. That's a pretty low, actually, if you go to see that. So for us, we said that the containerization is a strategic for us, which is basically means that we want to densify so that we can do a better cost optimization. So Docker or any container strategy became very natural for us, actually. So that's the second thing we are doing. It also aligns with our microservices, monolithic versus microservices, which means that every monolithic application, as we are decomposing into microservices, which basically means that container was helping us to basically deploy things faster. So we made the containerization as a third major thing. The fourth thing, which is no fear release, which basically means is that making sure that developers can push the code anytime, but without compromising on the quality, which means that. And the second thing for us is that we created what I call the push button deployment. That's what Ishu is going to show you how we have built this whole push button deployment, where developer can push the code, they can roll back, they can do canary deployment, they can do blue-green. It's a much fun deployment, the code. So now, from a situation where we used to deploy code maybe every once or 2 weeks, or maybe some teams used to push maybe once every month or twice a month, today we are pushing the code almost like 3 to 4 times a day, if team is ready, actually. So from a deployment, which used to be in the entire organization in the financial service, we're talking about maybe 10 to 15 releases in a month total entire thing. Now you're talking about hundreds of deployment. And what we are seeing here is that our business now are demanding that because they are enjoying the fact that they can push the features faster. So no fear release became a very central to our business. And in fact, I think Jeff Hazel, somebody said that any companies which has really empowered this entire software delivery, their bottom lines have actually gone up. So software delivery is becoming very important, not just for the tech, but also for our business, actually. So in CapitalOne, for example, somebody raised a question, how many C-level are paying attention to the software delivery? And I would say CapitalOne is one such company where our CIOs, our COs is paying attention to this. It's how critical for us. So I wanted to call that out. And the last but not the least, which is always on, which means that how many of you have dealt with the situation, at least I remember there used to be a time when the code has been deployed in the production, and the team comes and says, hey, I cannot find my log. Can somebody tell me where the logs are? Right? I mean, that used to happen, right? We wanted to move away from that mindset and something concept called shift left, which means that monitoring is by default given to you as a part of pipeline. That's the key here, which basically means that we also basically moved to a business track event, what this really means is that I know monitoring, always people think of CPU and memory utilization. I really don't know how many people are really paying attention to CPU and memory these days. These are commodity things. Everything is all about business event. right? So what we are doing is that we are enabling this through what we call the business event, which are making sure that every software that we are writing, we are making sure that team creates a business event, and since this is a real time we're talking about. So this is also something we have enabled as a part of the pipeline itself. And the second last, which is what we are talking about, is CTO and SLO. I don't know how many people will pay attention to it, but we are talking about SLO or SLA or CTO or KPIs, depends upon different terminology, different organization uses actually, but we are making sure that the monitoring is based on that. So we are talking about outcome-based, which means that, in fact, CapitalOne is guilty of that. I'm sure a lot of organizations, we have a lot of tools that we are used for monitoring, but still when we talk about the issues, we struggle for that. So what we are talking about is more around the outcome-based, and which basically means the CTOs and SLOs and SLAs are critical. We are trying to monitor based on that. What is the business wants, and make sure that we basically monitor based on that. So that's basically the always on. And finally, last but not the least, which is you build your own. How many of you are guys are going to this model of you build your own? Great, some of you are, exactly. So CapitalOne is going for a big, in terms of you build your own model, which means that traditional organizational of like IPS or what we modern call it a Google way of SRE. SRE is definitely a very important piece of the organization. But what we are doing here is we are force the developer community to say, you know what, if you build it, you need to deploy yourself. You need to carry a pager duty. That means if something goes wrong in your software, you need to fix it. And you know what happens? Software engineers are the most laziest people. That means when they find the problem and when they awake in the night and they have to fix it, you know what they do? The next day come and they fix the software. That's the culture shift we are seeing in the organization. Versus where it used to be where pager would come to an IPS guy, an operation guy, who would basically then do the initial troubleshooting, then call that. That whole model, we are trying to completely change that. So this is the last but not the least, but this is another shift we are doing that. So that's the sixth area I wanted to basically cover up. Now I'm basically going to hand over to Ishu and go over in terms of how we are doing that. Over to you, Ishu.
Thanks, Rajesh. I'm not sure I'll be able to meet your energy levels, but I'll try. So, how did we do it, right? So basically, when we started to break it down and Rajesh gave us the task that, hey, this is what we need to achieve, we said, okay, we had an existing pipeline already, which was working well for a few customers. And we said, okay, the pipeline was basically freestyle jobs. It was having certain build tools like Maven, Gradle, and it was a kind of a templates-based pipeline where if someone has to make a change, we were scared. Can we go and update that shell script? Will it break something for somebody? How do we make sure that we can unit test our pipeline, we can deliver more features? Let's say if a developer joined the company, he say, hey, I don't know anything about Maven. I've been very efficient with Gradle. How do I go and start about it, right? So we didn't want them to go and learn redundant technologies. We said, okay, you know this, let's see how fast we can support it so that you can go and start writing software instead of learning the way how we control versions, learning the way how we support which branching strategy. You just tell us what you want. We'll make sure that you follow some basic principles. As long as you do that, focus on building softwares. So again, so what we did was, as part of that whole process, we broke down our team into 4 different layers. We said, okay, now certain set of members will focus on onboarding the users. Certain set of people will focus on building a pipeline or CI/CD experience. Certain set of people will work on making sure that they can deploy the software in the best possible manner, and monitoring out of the box. That's what Rajesh just talked about. So let's zoom into what onboarding experience means. So let's say you have an idea, right? You want to put that into production. Today, you create a GitHub repository. You say, okay, I want to write a Spring Boot app. Let me go and create an archetype, get that app on my local. Let me push it to, let's say, dev environment, right? The first thing you find out, hey, I don't have Nexus or Artifactory access. Okay, let me go and talk to that team. You figure that piece out. Then the next thing is, hey, I don't know how to version my source control. Or maybe this doesn't align with my company. How do I go and figure that piece out? Okay, you learn that, you read some blogs, you figure that piece out. The next thing is, which is my Jenkins server? I don't know which Jenkins server is in CapitalOne. Let me go and read my intranet and figure that piece out. So there are hundreds of things that you learn let's say in a week or two, that you should have been not have been even worrying about, right? So that's like a boilerplate code or processes that should have been given to you. You should not have been worrying about those. Even though the teams in CapitalOne are doing amazing job in making sure Jenkins is always up, Artifactory or Next is always up, AWS is great, but to put things onto that, that's the least you should be worrying about. What you should be worrying about is, am I writing good code? Is that unit tested? There are no security issues in that, right? So we built a normal UI, I would say. We're in the process of enhancing it, but the bare minimum thing was, okay, get all the details from the developer on a nice UI. What is your repository, right? Which kind of branching strategy you want? What is your snapshot branch? What is your release branch? And give me the health check path of your application to make sure that when I deploy it, at least your health check passes, right? And what's your CNAME? Let's say it's aws.cloud.com. Hey, what's your context path? What do you want to access once you hit it? Do you want stickiness or not? What kind of testing, what's your performance test tool that you want to use? So we asked those basic questions from the user, and we sent a pull request to the user repository. And these are the things basically that we did right after they just pressed the submit button. We provided a Jenkins file by default. I'll talk about that in a minute. We created ALBs if the ALB is not present. We created CNAMEs. We created and customized their GitHub repositories based on if it's a Spring Boot project, if it's an NPM project, if it's a Python application. And as part of creating and customizing their Git repository, we also injected the best practices. Let's say this is the kind of versioning that you should follow. It's not restricted. If you want to use something else, go ahead and use it. But if you want to follow certain standard, you can. We have already set up the webhooks for you. We have already created the CI/CD pipelines for you. We have customized your package.json, setup.py if you're using Python, pom.xmls. Let's say we inject the main release plugin to your pom.xml so that when you create a release, your version numbers are already bumped up. We enable monitoring. We inject monitoring in your code. We'll talk about that in a minute. And set up your binary repository and provide you accesses wherever we can, wherever the accesses are provided through an API. And one thing that I want to call out here is Jenkins file customization. So I attended a great talk this morning from cloud.We's where they were talking about declarative pipeline, customizing your Jenkins file and all. So cloud.We is still to come up with a customization tool for Jenkins file. So basically, we did not want every user in the company to go ahead and figure out a Jenkins file by themselves, because most of the time they are repetitive, right? Most of the time, everyone do a static scan, everyone do an open source scan, everyone does a build, and everyone basically deploy to different environments, right? So most of the code is absolutely same. What it differs on is if you're using Gradle, if you're using Maven, Node, Python, as this, et cetera, et cetera. So what we did was we basically stored the template Jenkins file, and based on the input that the user provided on the onboarding page, we ran some commands and customized the Jenkins file and sent that as a pull request to the GitHub repository, so that when the user gets the Jenkins file in the repository, it's pretty much customized to the need that they have.
So if I may just add 2 points to what Ishu said, and this is a real fact. So we did a very, it was not a very scientific survey, but we did a survey among all the financial services pod, actually tech pod. What the survey came out was that today, before this, what we built it actually, the significant amount of time the team used to spend doing things outside writing a code. That used to be the case where, team would chase different teams, coordinate, make sure that infrastructure is ready, the pipeline is ready, access to this enterprise tools, so on. So team used to spend significant amount of time chasing all that. Just imagine that. Look at the productivity lost for an organization, right? And we are hiring a great talent, and what we are doing is asking them to basically go and do a bunch of coordination, actually. So we wanted to change that. The second metrics that we found was that on an average, and as all of us who are going through this microservice journey, we are basically decomposing all our monolithic application into very small component, right? Which means that more and more components have to be onboarded. what we found was that before we built this experience, on an average, a team used to spend almost 6 weeks before they could start writing the first code. Now, through this experience, we have brought down to less than 10 minutes. So today, when our software engineers, when they want to basically build, let's say, a UI or an API or BFF or a stream application or a batch, they come to this portal, and through this experience, they are able to get everything what they need in less than 10 minutes. That's the difference what we found. And what this has done is that this has improved the motivation level of our software engineers. So just wanted to call it out, that I just want to give you the context of why we did what we are doing actually. Thank you, Ishu.
Thanks, Rajesh. So after this, like, we did not just stored, created the Jenkins file based on the inputs. We stored that data in a Mongo collection, and we exposed that information for every component through an API. So basically, we provided more and more information to the developer with an API. The developer were enabled to create their own automation on top of that API. So for example, when you use a pipeline, we use shared libraries, which we'll talk about in a minute, but we internally made some API calls every time something happened. Let's say you ran the Sonar static scan, right? So we made an API call within our shared library and stored that information about that build in our database. So at the end, when you finish your build or when you finish your deployment, we can expose and build nice dashboard to show exactly what happened as part of your build. For example, I should have taken a high quality screenshots, but I didn't, I guess. So here you can, we basically deployed things in dev, QA, perf. You can find out which version is deployed, if it's deployed in which environment. Is it a Docker-based application? Is it a non-Docker-based application? And you can highlight the defaulters. You can highlight the teams which are not doing the right thing and specifically go and talk to them. So since the API was open, you can also build your own things for your own team. So that was about the onboarding experience. Now let's talk about the CI/CD experience, right? So this was the driving factor for building a nice transparent pipeline. So this is one of the code from my other team member who's a developer himself. He said that, okay, whenever I run a pipeline, I should not be asking or pinging 5 different people, hey, what happened to my build? Where do I go and who should I talk to? I'm smart enough. If you give me enough information, I'll go and figure out myself. I'll Google it. I'll find out the problem. And if I have to make changes to the pipeline and I stay within the boundaries, I should be able to do that, right? So here we leverage the concept of shared libraries. How many of you are using shared libraries today? Yeah,
awesome.
Like great, like 80% of you, great. So I'll just cover it in a minute. So basically, shared libraries are a GitHub repository for the lack of better words, where you can store your Groovy based code, and you can, whenever a developer makes a commit, and it can trigger Jenkins. Jenkins can basically pull that code. You can translate that into a CI/CD pipeline, and based on whatever input was provided in the Jenkins file by the developer, you can basically execute the kind of CI/CD pipeline that they want. So that actually enabled us to build great transparency in the whole process. And what we did was we built a shared library project within the company. We ran it as an inner source project. Like you can see on the left, this is the Git repository for that project. We have 17 contributors, even though like there was just a 2-member team, me and my partner Daniel, and we had 15 different developers. One of them is here, I think, Grant. We went ahead and asked their different requirements. They were kind of a DevOps lead of their own organization. They said, hey, my team needs this requirement. My team needs this functionality in the pipeline. So we built this through a inner source project where every team created an issue. We found out the urgency of that issue. We asked someone to come forward and contribute to the common pipeline. And we went ahead and created nice documentation for it so that people can just go to the documentation, find out all the modules those are available through that shared libraries, copy and paste it in their Jenkins file, and just move on, right? So we also, on the right-hand side, this is a sample Jenkins file example. So one thing that we did with our Jenkins file is we made it very, 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 very configuration centric. We did not put complex logic in it. We did not put any if conditions, else, or some for loops. We wanted to avoid that. So all we did was we followed the groovy closure concept, where a developer can just provide the basic inputs that they want. For example, hey, I wanted to provide, hey, this is my Maven argument. This is the version I want to tag my Docker image as, right? So you can just go to the documentation, see which closure basically accept that input, and go ahead and build that, go ahead and pass that value. Now, you will also see that maybe if it's visible through, sorry for the bad resolution, but we have a concept of snapshot and release closures. So if you make a commit to the snapshot branch, we provide you a little leniency. We don't enforce all the checks, even though you have an option to opt in for them. But if you don't want, you can say, hey, I don't ingest a security bug in every single build, right? So let's say you build it once, there are no security problems, you can skip it for the next build, but only for snapshot. So snapshot, in my opinion, is a kind of artifact which is temporary and which can be overridden and which cannot go to production. So those three things makes an artifact snapshot, in my opinion. So we made sure that you can have leniency on that so that you build faster, your builds doesn't take like 20 minutes. You can skip security if you want, only for snapshots. For release, if you make a commit to the release build, on the left-hand side, you can see we put this admin kind of code in our shared library where we make sure that if your code doesn't have static analysis, if your code doesn't have a security scan, and if you are running in a release branch, we will fail your build. We will not allow you to move forward. Similarly, we can build things like, hey, if your code coverage is below 80%, we cannot allow you to go forward. So you can enforce those kind of standards as a company and change the culture. One of the very common thing which sounds very obvious is committing to your release branch through a pull request, so that you at least have two set of eyes. Someone is creating a pull request, the other guy is approving it. So you will be surprised by the amount of people who are not doing it, right? And they did not know it until we stopped them. So we also built that in the release closure. We said, hey, if you are creating a pull, if you are committing a code in your release branch all by yourself, it doesn't matter if you are an admin, it doesn't matter if you have write access, but if you if you are the only person who's committing it, we don't trust you, we'll fail the build. Again, so we thought about more closures, and these are one of the few closures that I just wanted to call out. For example, branches closure, right? So when we started this project of shared libraries, we met with a lot of teams, asked them, hey, what's your branching strategy? Are you using a single branch? Are you using multiple branches? How does it work for you? So we spent weeks in that conversation, right? Everyone has their own opinions about branching strategy. There are people who say, hey, you should use a single branch. There are people who say, I don't like single branching. It doesn't work for me. I have like 5-member team. I want to make sure that there are multiple features, right, at one being worked upon a single time. So what we did was we created a closure called branches. We said, okay, you can, like, if you are working in a development branch, you can just say, hey, this branch, whenever there is a commit to this branch, enable snapshot behavior. Whenever there is a commit to the release branch, enable release behavior, right? So whenever you make a commit to, let's say, master branch, which is tagged as release branch here, we will make sure that it follows all the right standard, and we store the version that is created by that commit and store it in a database and say, hey, it was built through release. So even though you flip snapshot and releases and everything, we are storing all that behind the scenes, and you don't have to go and talk to some team saying, hey, can you change the name of my release branch? We can, that power was given to the developer, and they can control that behavior through their branches closure. So after that, the noise was gone. Like, people could try the branching strategy that they liked, and they could just control it from their Jenkins file. The right side is pull request closure. The teams were basically, we gave this power to the teams. We said, okay, these are the bare minimum things that you need to do. You need to make sure that you have, whenever there is a pull request to your release branch, is it installing? Is it compiling at least? Is it following the, is it at least linted or not? The third thing was basically checking the test coverage. We provided this flexibility. They can just mention that closure. If they want to make sure that the code coverage is above 80%, they can just add that closure and move on with it. Similarly, you can also control notifications. You can say, hey, if I want to send emails for the success. I want to send emails in case of only failures. I want to send Slack messages and everything. You can control all that by your Jenkins file. I think this concept was very unique too. What we did was we made the Jenkins file as simple as possible. We did not, so today if you write a Jenkins file and you execute it, it just executes all in one shot, right? One step is executed right after the another. But there can be certain scenarios where you don't have to execute all the things. And we did not want you to write if, else, and for loops and other conditions to make it hard to maintain, hard to scale. So what we did was we created a logical flow within the Jenkins file, and we controlled that flow in our shared libraries. So the way it works is you see your branches closure on the top left. Let's say if a commit is made within your development branch, the flow goes later. It checks whether what kind of branch it was committed in. It was committed in a snapshot branch, so only snapshot closure executes. After that, once the snapshot closure execution steps are done, it goes forward and deploy only to your sandbox environment. Similarly, if on the right-hand side, if there is a commit to your master branch, we only execute the steps mentioned in the release block, and then similarly, we deploy it to the corresponding environment in the deployment closure. So we created a very logical flow with the Jenkins file where a developer can just move the blocks up and down and basically define what kind of execution should it be. And I think this is my favorite part, continuous deployment. So I'm sure you guys are using CI/CD with Jenkins. One of the big problems that we had for CI/CD was the deployment is sometimes very hard, right? It can have hundreds of scenarios. It can have various use cases that can happen or could go wrong, could go right when you are deploying your application in cloud, right? So what we did was we took that logic out of Jenkins. All the Jenkins was doing was it created a payload like, hey, deploy my application to this cluster, and this is the version I want to deploy. The rest of the things were we basically built in a Lambda function, which is again serverless. We took that payload, and behind the scenes we ran the corresponding logic to against ECS. We can even extend it to other cloud provider if required. Let's say if you want to deploy it to EKS, tomorrow if you want to deploy something in Azure or Google Cloud, anywhere, we can just do that without making any change on Jenkins. And we can also basically source control the kind of deployment capabilities we want to provide to Jenkins. And there was a separate team which is working on just the deployment capabilities. So with this model, we could accelerate the blue-green deployment, the canary deployment, the rollbacks, and various other things. One of the things that also came out of this model was whenever the EKS or ECS responded with a kind of deployment message, we could put extra logic in our deployment manager, parse that, and provided more human-readable errors to the user. So that if, let's say, we deployed a container in ECS, right? That container failed within, and it just did not come up on ECS. So we ran extra logic, found out the log exactly. We said, okay, the message we showed on Jenkins was your container was not able to come up within a certain amount of time. Go and log into your container. There can be X reasons of the failure. So the user was made more smart in taking the next step, finding out what exactly happened as part of their deployment.
So if I may add two things to what Ishu said, right? One was that we moved the entire deployment logic out of Jenkins, and not because Jenkins is not great. Jenkins is a great product, but we made a strategic decision. The second part of the conversation, what Ishu highlighted was that on the right side, if you see, we have right now using AWS ECS, right? And in future, I know Kubernetes is a hot topic. Everybody's trying to gravitate towards the Kubernetes. And as a part of multi-cloud strategy, that makes sense actually, right? So what we are doing here is that by moving on the right side from ECS to Kubernetes to Google Cloud or Azure, we are still keeping the deployment manager independent of it, which basically means is that we have built this wrapper on top of the orchestration layer, where very much a logic that is very much centric to CapitalOne, what we have built actually, is all codified within the deployment manager, which means that today, neither on the left side, neither on the right side can make a difference to the deployment manager. So it's a very strategic decision we made, and it's paying a good dividend to us. And today, when we are thinking of basically looking at other container strategy, we are very confident that we can change the right side with very little amount of disruption on the deployment manager side, but with absolutely no change on the left side. So that's something we wanted to call it out. Thank you.
Thanks, Rajesh. Okay, and like I said, Hygia, I think Rajesh mentioned it earlier. Hygia is a data-driven tool for CapitalOne where we send all the information to Hygia, and Hygia can build cool dashboard for your application. It can show exactly what your build status is, what kind of deployment, what kind of environment your application is in right now. This is completely open source. You can go to github.com/CapitalOne, and you can download Hygia, install it for your company. And right now, Walmart and Verizon are using it heavily. They are really a big fan of it. They are coming back and contributing to it as well. You can go and find out about it more from the booths that we have, and you'll definitely like the product.
And so to add to what Ishu said on the Hygia, we are also using Hygia as a think of it like an audit capabilities for us, which means that as we are deploying code in production, we are asking Hygia, has it met all the guidelines, the rules, or the standards that is required from a release management perspective? If answer is no, we basically don't allow you to deploy that. So Hygia is also acting, in addition to a dashboard from a DevOps perspective, it is also acting as an audit platform for us. Why? Because it has all the data. It has all the data, right? Data speaks for itself. I don't need to cook up any data, right? As long as the Hygia has the data and Hygia can tell me that has it met all the requirement. If it meets, I allow you to basically push the code. If not, sorry, we cannot deploy that. So we're using Hygia in multiple ways. I just wanted to call it out.
So yeah, so moving on to the next step was building the release experience. So like Brijesh talked about earlier for no fear releases, right? So these are the basic principles that every company follows, right? For most of the companies should follow about the releases, right? To make sure that every change that is being deployed to the production is peer reviewed, everything is under source control, production changes are only through the code change, access to production server is properly governed, and on and on. So like in CapitalOne, we have a unique concept of making sure that the things that you're deploying right now, we check that through code. So imagine like the reason we used to plan for a week or 2 weeks or 3 weeks in the past was we used to make sure manually if these things are being done. But today we have a system in place where if you are deploying something to production, we either have done it already on the left-hand side of the build process, or during the production deployment time, we can make API calls, let's say to your Git repository, right? And we can figure out if there is a commit that was not done through the peer review. And if that is the case, we stop you from going to production. And similarly goes for your blue-green on canary deployment. So let's say if you are trying to deploy your application through a pipeline, which has a capability of rolling back your change very fast, or even before making it live, if you have your staging deployment in such a way that we can find out there are problems if you make it live, we allow you to allow that to go to production immediately. And similarly, if your pipeline has a way of providing evidences, right? So if you're deploying a version to production, at the same time, if you provide evidences to our system, whether there was a proper performance test done for this particular version, if the proper functional test was done for this application. If you can provide those evidences, there is no problem. There is no reason to stop you from going to production. So to make that happen, again, we did it through an API, through API model. We built a UI on top of it. You can just select your application. You can select the version you want. Let's say if the tests were failing for it, we don't allow you to go forward. We also maintain all the historic data. So let's say if you want to roll back, you can just select the version that you want to deploy that was working for you, and you can just choose that and deploy to production. We have various different features when you go to when you try to release a product. You can say, hey, either you want to directly deploy it to production, or you want us to, or you want someone else to go and first validate the staging and then let it go to let it make it live. And now I'll hand over for the monitoring session.
Yeah, and I know we are almost out of the time, actually, so I'm just going to quickly glance over. So as you can see, I don't know how much it resonated with you. We talked about do the right thing, always on, no fear release. So everything, I hope this resonated. And finally, I just want to talk about quickly the monitoring. So if you look at from a monitoring perspective, we are focusing on these, what I call the 5 areas, making sure that we are a metrics-driven organization, which means that whether we are spitting out tech and business events, we are definitely logging. Those of us who are a big fan of logs, we spit out a lot of logs. Tracing, it's very important for us, right? And you want to basically see end-to-end whether this thing. Of course, the key here for us is the visualization and, of course, alerting and notification. So if you look at the technology stack, we have built the concept called observability, which is gaining a lot of attention these days. So we are making sure that our JVMs are properly monitored, low-level monitoring, we have introduced that. And then in addition to that, we are also monitoring at the low level, which is that we are making sure that Dockers are monitored. We are using a Fluentd right now for shipping all the logs to Kinesis and then to Elk, actually. We are also basically using the C advisor. So just in the interest of time, the bottom line here is we are making sure that from the host level to the container, to the application, to the JVMs, everything is basically monitored. And these are not monitored afterthought. These are all enabled as a part of your experience itself. That's what we're doing that. And then what we are doing is that this is basically the dashboard. And right now, of course, we are using a Grafana for our dashboard. This is basically a Google, the 4 controls we're talking about, the latency and the errors and the traffic and the saturation. And this you can see here on the business metrics and tech metrics. So what this really means here is that when a component, and when I talk about a component, I'm talking about a single Git repo, which is onboarded to our pipeline, by default, you get this dashboard right out of the box, which used to be like a big hassle download because people will say, hey, where my logs are going, where my data are going, I need a place to view that. Now this comes to you part of default itself. So we made a shift on the security side and the monitoring side by doing basically a left that. So with that, I think we are almost at our time. I don't know if we have time for question, but we'll be more than happy to stay back and see if answer question. But thank you so much for taking time to attend this session. Hope it was helpful, actually. Thank you.
Yes. Next slide.
Yes, sir. Sorry? What kind of automated testing we run the pipeline?
So we say that. Please repeat your question again. What kind of automated testing we have in the pipeline?
Yes. So let me answer the question. So I think there's a booth outside called NeoLogger. Actually, there's something. Yeah. So we have built our own internal tool concept called 7PS. It basically enables you. It provides you a lot of different automated tests. The thing like, for example, let's say we have enabled Sauce Lab, we have enabled BlueHub, we have enabled JMeter. You name it actually from that. So the goal here is that when a developer comes to the pipeline, they have to choose which agent through which they want to run their automation testing. So we enable your functional and performance testing based on the agents that they basically select that. I don't know if I answer your question or not.
Next slide.
Yes, sir.
I'm curious about how you socialize with this initiative. I met a company with 100+ development teams, and they've all got their own ways of doing things. They want to continue doing things their own way.
Great question.
Great question.
Yeah, that's a great question. I think in the previous session, KPMG session, somebody talked about that, hey, unless the C-level, the top-down, I think for us, I think we have been lucky enough because our leadership sees the value of it. So I think the push has also come from top-down. But at the same time, we have made sure that the way we are building things, we do not basically create some kind of a suffocation for a developer where we are tying their hands. So we are trying to balance between what is the right for the organization, but at the same time making sure the developers feel that they have been empowered actually. So to answer your question, our leadership have played a very important role in making sure that we create this culture of DevOps actually. So that's a great question. Thank you. Yeah.
Next slide, Rajesh.
And last question, CapitalOne is always looking for great engineers. So, if you're interested, join us actually.
Come meet us. Give us your resumes.
Thank you all. Thank you all. Thank you.
Thank you.
Thank you.